lot of people were missing school today, and some for very good reasons. Okay. For example, we got our friend Nicole, who's at Chamber. John, who says he's at Chamber, but who really knows, right? We got Henchi, who's sick. Tell you what, first person to watch this video, and we got to have a code word to make sure that they watch. What should the code word be? No. Cucumber. Code word is cucumber. Whoever can come up to me and say cucumbers, watch this video. That's your. That way I know you watch it. You can have your choice between oatmeal, cream pie, or fudge roll. So there you go. Take that. All right. So yeah, maybe people start watching the videos more than cucumber. No, that doesn't count. You're here. Okay. So we want to be able to answer some word problems. You guys say, when in life will we use this? And I know that you might not end up, being in the Navy or something in navigation, but this is a definite part which gets used. Looks like a complicated question. Two ships leave a port at noon. Ship A is traveling at a bearing north 32 degrees west at a speed of 5 miles an hour, and ship B is traveling at a bearing south 75 degrees east at a speed of 4. How far apart are they at 4 p.m.? Where to even start? Let's start by drawing a picture. We say that this is the port right there. And it says north, 32 degrees west. I would say that that would be approximately like that. Can we be okay with that? And then I've got south 75 degrees east. Wow, that's a big turn to the east, isn't it? So I've got south 75 degrees to the east. So that's going to be 75. And the question is, how far apart are they? What is that distance? We don't use the unit circle. We are going to use the law of cosines, but if we use the law of cosines, don't we need an angle? You could label the sides. What do you label the sides? Why would you call this 16, Brecken? Very good. 4 miles an hour from noon to 4. So 4 hours at 4 miles an hour, that makes 16 miles. And then if you look at this one here, 5 miles an hour for 4 hours, that's going to be how far? 20. And there you have it. We need an angle, don't we? Wouldn't it be nice to know this green angle right here? You know it. Oh, what is it? How do you know it's 137, Alex? Okay, so you got 15 there added to 90 because you got 90 there, and then you add 32 and you got 137 degrees. Wow. So I've got side angle side. Would everybody agree that it's now an opportunity to use the law of cosines? Sure. I can say that d squared is equal to 20 squared plus 16 squared minus 2 times 16 times 20 times the cosine of the included angle, which is 137 degrees. Take out my calculator, and I go 20 squared plus 16 squared minus 2 times 16 times 20 times a cosine of 137. And I get that thing. Is that my distance? No, I have to square root that answer. And sure enough, I get 33.53. So that distance is 33.53 miles. Does that sound like a reasonable option for a distance? Why? Okay, can somebody give me something more assuring than simply they're going slow? Largest angle corresponds to the largest side. I like that. What if I would have come up with 37 miles? Would that be okay? It wouldn't. Why? Why? Jarrett? 20 and 16 make 36. If you put them straight apart from each other, they'll be 36, right? Yeah, the other side has to be less than those both combined. So 37 is too long. 35 would still be reasonable. 34, but 37 too long. Good. How about we switch vehicles? We go from a boat to a plane. And we're going to call this north 20 degrees east instead of north 70 degrees east. But it says a plane is traveling at a bearing of north 80 degrees east. What direction does north 80 degrees look like? What does that look like, north 80 degrees east? Is it up? Is it sideways? Where? So north and then 80 degrees east, right? So we're going to be like this, right? So that's an 80-degree bearing. And it flies for 300 miles in that direction. And then it turns and it flies at what bearing? At a north 20 degrees east bearing. How's 20 degrees east going to look like? North 20 degrees east. Okay, so north and then just It's a good effect. Appreciate that. So that's a 20-degree bearing, and it says 400 miles in that direction. The question is, how far apart are they? Well, I've got two sides. Boy, I sure wish I could find that angle. Maybe you can after you get some brain food. Oh, man. Okay, so this is the question. If I'm heading at an 80-degree bearing, and then I turn and I'm heading at a 20-degree bearing, I need an angle. I'm hearing some options. What is it actually? You tell me. Why is it 120, Mr. Henrik? Okay, you are correct. That's a challenging way to think about it. I'll give you an easier way to think about it. If you're going at an 80-degree bearing and you turn to 20, what's your turn? You turned 60. And so there you see it add up to 180. Okay? So you can do it. Henrik put together a little compass. And so what he did is on that compass, he said if it was 80 degrees, that's going to be 10 down there. That's going to be 20 up here. 10, 20, and 90 makes 120. That you can think about that way too. And so good job, Henrik, thinking about that way. I think the best way is to think about your angle of turn. Whoa, don't do that. What just happened? Did it just go away entirely? Or is it? Okay, good. New page. We'll just go back. Okay, so I've got my angle. So if I have side angle side, what do I use? I use law of cosines. D squared is equal to 300 squared plus 400 squared minus 2 times 300 times 400 times the cosine of 120 degrees. It is a big number. 300 squared plus 400 squared minus 2 times 300 times 400 times the cosine of 120. And I get that thing. If I square root the answer, I get 608.28. 608.28 miles. That is, in fact, how far apart they are. Any question on that? Okay, we have two left. Point A is due north of point B. Point C lies to the west of both. If AB is 12 and BC is 13 and AC is 15, what is the bearing of C from B? The other way you could read this is B to C or A to C. I want to figure out the two bearings. If I could be able to figure out bearings, what do I have to come up with? I currently have 3 sides. I need an angle. I've got side, side, side. If you have side, 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 what do you use? Law of sines or cosines? Law of cosines. And if I use the law of cosines, which angle do I start by finding? The biggest one, which is going to be angle B, because it's opposite 15. So therefore I have 15 squared is equal to 12 squared plus 13 squared minus 2 times 12 times 13 times the cosine of angle B. How do I solve that? What do I do? What do I do? I subtract the 12 squared. I subtract the 13 squared. I get negative 88 is equal to, and on the right-hand side, you have negative 2 times 12 times 13 is negative 312 cosine of B. Do I add the 312 or divide? Divide the negative 312, and I get 0.28205. I inverse cosine, and I get 73.62 degrees. So I'm looking for the bearing B to C. Describe the direction to go from B to C. Describe the direction. North, west. How many degrees to the west do you turn? 73.62 degrees. Now I have A to C. If I want to do A to C, what angle do I need? I need A. How do I find angle A? Law of sines. The sine of 73.62 divided by 15 equals the sine of angle A divided by 13. Sine 73.62 divided by 15. I inverse sine, and I get 56.25 degrees. So, describe the direction of travel. So, 56.25 degrees west of that south line. So we've kind of put together a lot of the things we've used so far, right? Well, the truth of the matter is, folks, the test that you have on Tuesday next week, I could simply just make it a one-problem test, because example 5 covers all of the things that we've talked about. Wouldn't it be nice if the teacher told you what you're going to have on your test? You will have this problem on your test. The numbers will be different. I'm pretty transparent about what's going to be on your test. A few times I'll be this transparent. You will have to do this. And so for me, it's a great gauge. I can see that when I tell you directly what you will have to do, and by the way, you have a problem like this on your homework and on your study guide, it is full preparation for you to be ready for this test. It's worth 6 points. The test is worth 48 points. That means that this is 1/8 of the test, or 12.5%. You can't do it, you've lowered your grade by 12% already. Got it? Who here has the largest plot of land? Would it be the Lane farm? How many acres do we have on the Lane farm? 10? Maya? Yeah, 1,000 acres. So we've got the Jensen farm right now. Brecken, more than 1,000? About 3,000 acres. Wow. Now, those who own a large piece of land, is it shaped like a perfect rectangle? No. Calculating the area of odd shapes can be challenging. For us, because we're excellent at mathematics, it is easy. Suppose you have a piece of land that is bordered by a river. This side is in fact 285 feet. The top is 564, and this side is 322 feet. And you have angles of 98 degrees and 105 degrees. Can somebody think, because I don't have a formula for a quadrilateral. I got formulas for squares, for rectangles. But what about this? How are we going to find this area? Exactly. This is how it's actually done. We use a lot of technology to make this happen, but you have to give the technology the two angles and the three sides. Land surveyors do that work. So, this is something that I did. We would use electronics to do it, but I could do this by hand. Um, and my dad is a land surveyor. Back in the 70s, he used to do these problems by hand. You'd have to know how to do the trig. So we want to calculate the amount of area here. Great, I've got two triangles. Triangle 1, triangle 2. Do we have enough information to tell the area of triangle 1? How do I do the area of a triangle? 1/2 times? We got a different formula because we don't have a right triangle here, folks. Do you remember what we do? 285, 564. You just multiply the two sides together times a half, so it's kind of like 1/2 base times height. Then you have to multiply by something else. Do you remember? Sine of the included angle, sine of 98. And that's going to give to you the area of the first triangle. So when people write IDK on this problem, I know that they haven't worked very hard. They can't even tell me the very first area. All you have to do is divide it into a triangle, and there you have it. And we've got 79,587.84 feet squared. It is a lot of feet squared. Happens to be short of 2 acres. Isn't an acre of land around 46,000 square feet? Great. How about triangle 2? So you would like to find C, so you have a second side. Then we'll figure out the angle later. Everybody agree we can figure out C by using the law of cosines. C squared is 285 squared plus 564 squared minus 2 times 285 times 564 times the cosine of 98. I take that, type it in, 285 squared, 564 squared, minus 2 times 285 times 564 times the cosine of 98, square root the answer, and I get C. Oh boy. Ew. Is that a bad omen? Should we just stop? Yeah. Whatever, there it is. What is it? Just a number. Now that we've got that, now what do we do? You could find the river length, but you don't need to. Don't we just need an angle? We need angle B, don't we? We can't find angle B right now, but could we find angle A? How? Sine of 98 over what? 666.38 equals the sine of A over 285. If we do that, that will give us angle A. 285 sine of 98 divided by C is that sine inverse the answer 205.057 or 25.057 degrees. If we know angle A, can we find angle B? How do you find angle B? Yeah, don't subtract from 180, but subtract from 105. 105 minus the answer. You can see we have 79.94. Is that enough information to now find the area? Yeah, I've got 1/2 times the two sides, which is 322 times 666.38 times the sine of 79.94. Six 666.38 times sine of 79.94. I get 105,637.6792. 105,637.68. If I want to find the total area, I just add on to that 79,587.84, and I get a total area of 185,225.5192 feet squared, which is approximately 4 acres of land. You will have to do a problem like that on your test. If you don't come out to the nearest hundredth, that's fine. I like to, in this, an example like this, I'd like to be with you to be within 10 feet. And you shouldn't have a problem with that at all. What do you think? That is your last problem for the unit. I'm ready to now hand out your assignment, but there are a couple changes. Okay, folks, you changed problem 1 to that. Problem 2, A and B are those.